Hello! This lesson is entitled Photoelectron Spectroscopy, or PES. Photoelectron, or photoemission spectroscopy, employs the photoelectric effect to measure the binding energies of electrons in atoms. The data is most commonly communicated in graphical form, like we see here on the right side of the screen. PES data is strong evidence for the shell and subshell model of the atom. This is a very important idea. That's why there's a double asterisk by it. You need to know that the data that we get from photoelectron spectroscopy is very strong evidence of the shell-subshell model of the atom. So, how do we read one of these graphs? Well, firstly, innermost to outermost electrons are from left to right. So on the left here we have the electrons that are closest to the nucleus, and as we go to the right, those electrons are further from the nucleus. You can see that typically the energy scale, which is on the horizontal axis, first of all, it is almost in reverse numerical order. That is, the larger numbers are on the left, the smaller numbers are on the right, and typically this is more like a logarithmic scale rather than a linear scale. Now, why is this? Well, the reason is because the innermost electrons are held very tightly. The outermost electrons are not held as tightly. So the outermost electrons have a lower binding energy to the nucleus compared to the inner electrons. Secondly, the blip height indicates the number of electrons in a subshell. Now this is a bit of an idealized photoelectron spectroscopy graph. However, the height of the blip is indicative of how many electrons there are in a particular subshell. So, in the case of this drawing, this blip represents the 2 electrons in the 1s orbital. The next blip represents the electrons in the 2s orbital. The next blip, which is, as you can see, 3 times higher than the 2s2 blip, is the 2p6 electron shell. Then we have 3s2, and let's see, what would this next one be? 1s2, 2s2, 2p6, 3s2, and next comes 3p. 3p what? Well, this one is twice as tall as the 3s2 blip, so our best guess would be 3p4. And if we were looking at this on a periodic table, we would count that there are 16 electrons there, and that this graph might represent the element with 16 electrons, that is silicon. So let's try a couple of problems. Determine the element represented by the following photoelectron spectroscopy graph. Well, 1s2, 2s2, 2p6. I trust that you already know about electron configurations, so I'm not going to go into that here. 3s2, and then here the blip height is roughly half of the one before it, so this must be 3p1. If we count up electrons here, we have 2 plus 2 plus 6, that's 10, plus another 2 plus 1, that's 13 total. So that's going to be the element aluminum. Now let's draw an approximate PES graph for chlorine. So we find chlorine on the table, and it has 17 protons and 17 electrons, assuming that it's a neutral atom. And the electron configuration for chlorine would be what's shown here in the lower right: 1s2, 2s2, 2p6, 3s2, 3p5. So what we need to do is draw a graph. The vertical axis represents the relative intensity. The horizontal axis represents energy. We would draw a 1s2 blip a 2s2 blip at a lower energy. Remember, the energies go from highest on the left to lowest on the right. 2p6, 3s2, and now 3p5. Remember that the number of electrons is indicated by the height. So we would expect a blip not quite as high as the 2p6 blip, 3p5. Thanks for joining me.